Hello students, in today's session we'll try to learn the following concepts: electric energy, electric current and electric circuit. Now let's begin with electric energy. Let us all first try to understand the meaning of energy. Energy would be the capability to do work, or when some work is done, energy would be transferred from one body to other body. Talking about two basic forms of energy, we have one kinetic and the other potential. If you were to define kinetic and potential, kinetic energy would be the energy possessed by the body by virtue of its motion. Potential energy would be the energy possessed by the body by virtue of its possession. So these are the two kinds of energy we have learned. These were the basic concepts that we have learned in the class 9 chapter with respect to work and energy, that chapter. Being specific with the chapter, this chapter I mean class 10 chapter 12 electricity, let us try to understand why electric energy or electricity much more useful than any other forms of energy we know. Beginning with the first point, as compared to other forms of energy, electricity has the following important advantages. One would be it is the most convenient source of energy. It can be readily transmitted over large distances with relatively smaller loss in energy. Third, it can be easily converted into other forms of energy like heat, light, sound, motion, etc. So I repeat those points. One, it is more convenient to use this form of energy, and also it is very easily transmittable or being transported from one place to other place. The third point is the conversion rate or the method of conversion would be very easy with respect to electric form of energy. Okay, this was the introduction of energy and electric energy. Before moving on to the concept of electric current, let us try to learn regarding charges. To understand this concept of charges, I'd like to refer the chapter Atoms and Molecules and Structure of Atom from class 9. In these chapters, we've learned regarding atoms and molecules, various theories of atoms, and what does atom exactly contain. We also learned that atoms consists of central nucleus, that is the atomic nucleus, and the electrons are revolving around that nucleus in their specialized orbits. So this is a part of atomic theory. Relative to this chapter, for time being, please remember whenever I say a charge, it can be a positive charge or a negative charge. So whenever it is a negative charge, I mean they are electrons. With respect to kinds of charges, we have two. One is positive and one is negative charge. And electrons carrying negative charges are the ones which can move and generate electricity. So more insight into this concept of electricity and charges will be dealt in class 12. But as of now, let's try to understand this point that we have two kinds of charges. One is positive and one is negative, which is responsible for generation of electricity. Summing up till whatever we have studied till now, we have discussed what is energy and more regarding electric energy and something regarding charges. And of course, we have two kinds of charges, positive and negative. We are more concerned with negative charges, which are electrons, which can move. That's what the property. Okay, so the property of electrons is they can move and they can generate electricity. That's what we'll be understanding in the further concepts. Okay, moving on, let us now denote the charge as the letter capital Q, and let us denote electric current as capital I. Now it's time to define electric current. So if you look at the definition of electric current can be defined as the ratio of charge upon time, that is I is equals to Q by T, as you can see on the screen. Here I would represent electric current, SI unit ampere. Q would represent charge, SI unit coulomb. T would represent time and SI units seconds. So whenever you learn a formula in physics or with respect to science, please remember you have to always go with the SI units only. Even while solving numericals, when you get the answer, please mention the SI units. Do not forget this point. So we can also define electric current as follows. Electric current can also be defined as the flow of electric charges across the cross section of a conductor, which constitutes an electric current. For instance, a stream of electrons moving through a conducting wire constitutes an electric current. I've already mentioned that we have two kinds of charges, positive and negative. When the negative charges, I mean the electrons, when they move, they constitute something called as electric current. So these were the concepts of electric energy and electric current. Now let us try to 1 ampere. Please do remember that 1 ampere would be the SI unit of current. So whenever we define 1 ampere, it also means that we are defining the SI unit of current. Now the question is, how do we define 1 ampere of current or its SI unit? We've learned that I is equals to Q by T. The ratio of charge upon time would mean electric current, or it can also be defined as the rate of flow of charges. We have I is equals to Q by T. If charge is taken as 1 coulomb and time under consideration as 1 second, then we have I is equals to 1 ampere. For Q, the charge taken as 1 coulomb and time T taken as 1 second. Fine. Hence, we define 1 ampere of current or the unit of current as follows. Now the definition goes like: ampere is the flow of electric charges through a surface at the rate of 1 coulomb per second. I repeat the definition. Ampere is the flow of electric charges through a surface at the rate of 1 coulomb per second. That is, if 1 coulomb of electric charge flows through any cross section of a wire for 1 second, then it would be equal to 1 ampere. And that's how we define 1 ampere of current. Now, let's try to learn about conductors and insulators, and we'll also try to categorize some examples under conductors and insulators. Most of the materials can be broadly classified into two categories. One is conductors and the other is insulators. Now, let's begin with conductors. Conductors are the substances through which electric charges can flow easily. For example, the electrons of the outermost shells of metallic atoms are loosely bound to the nucleus. These electrons are quite free to move, so metals have high electrical conductivity. Whereas insulators are the substances through which electric charges cannot move freely. In insulators, the electrons are tightly bound to the nucleus and cannot move away from it. As the electric charges cannot move freely in insulators, so they are poor conductors of electricity. So from this we conclude that conductors will allow the charges to move through them, so they are good conductors, whereas insulators, they are poor conductors of electricity. Now some of the examples of conductors are like metals, copper, silver, aluminium, graphite, as well as human body, acids, alkalis, as well as water solutions of salts will include the examples of conductors. If we were to look at some examples of insulators, it includes diamond, rubber, glass, wood, plastic, and distilled water.